In this live class, we want to look at this topic briefly in mathematics. That is matrices and determinants. So what is a matrix? When you talk about matrix is a rectangular array of numbers that is arranged in row and column. So when we arrange, we can define a matrix as rectangular array of number arranged in rows and column and enclosed within a large bracket. So when we give, for example, we have 5, 1, 3. That's the first row. The second row, we have 2, 4, minus 3. So for this matrix now, we have 2 rows. This is row 1. Then here we have row 2. And we have 3 columns. We have column 1, column 2, and column 3. We have 3 columns here. Then when we talk about matrix, there is something called order of a matrix. The order of a matrix is usually given as row by column. So it's orderly arranged. Row come first before column. So anytime we are naming a particular matrix, so we put the row first before the column. Just like when we talk about the Cartesian plane, we talk about x, y. So x is usually coming first before y. So in the same way, when we talk about matrix, the row is always pronounced first before the. So here we talk about row by column. So this matrix is now of order 2 by 3. Why is it like that? We have 2 rows and 3 columns. So that is that. Then matrices is denoted. We have notation of a matrix. Matrix is usually denoted with capital letter. Notation. We use capital letter for matrix and small letter for the element inside it. Like for instance, we have a matrix A, which are the way we have it. We can say we also have another 2 by 3, like 1 minus 3, 0. And also we have 2, 4, minus 4. This is also a 2 by 3 matrix, whereby this is represented. If we want to represent it with letter, small letter here now, this first element is referred to as A11. What does that mean? Element in row 1, column 1. The first number here starts for the row, the second is for column, like we said, ordered pair. Like we have the first is the row, the second is the column. So row 1, column 1, and here we have also row 1, column 2. Here also we have row 1, column 3. Here also we have row 2 now, that's A21, row 2, column 1, row 2, column 2, row 2, column 3. So this is what we have as the notation of a matrix. So for example now, in this matrix now, we can say we should identify or determine the elements A13. So the element A13 here means the element in row 1, column 3. So we will just write it out here. So we just write it out here, and we say the elements in the row 1, column 3. So that will give us 0. Sometimes you might be given anything to find. Might be A22. So what is A22 here? Element in row 2, column 2. Row 2, column 2, that's 4. So that is the notation of a matrix. Now we have some types of matrices. When we talking about types of matrices, as the name implies, we have the first one. We can say we have a row matrix. A row matrix. This type of matrix has just one row of elements. So their order is always one by anything. So row, just one row. And also we have a column matrix. This one has just one column. So it will be something by 1. So column is 1. So that is that. We have what is called zero or no matrix. We have zero or no matrix. Here, all the elements in that matrix will be 0. So they have 0 throughout those elements. Also, we have something called a square matrix. A square matrix. This has the same number of rows and same number of columns. E.g., you can have 2 by 2. The row is 2, the column is 2, or 3 by 3. So we call those type of matrix a square matrix. Also, we have what is called diagonal matrix. It only have elements that are non-zero in the leading diagonal. So that's diagonal matrix. So we also have identity matrix. All the elements in the leading diagonal are 1. That's identity matrix. And those are the type of matrices we have. Now, very quickly, let's look at addition and subtraction of matrices. Addition and subtraction of matrices. So how do we perform basic operation that is involving matrix? So now we shall quickly look at the method general. So addition and subtraction of matrices. So now generally, if we have matrix A given as a, let's use a 2 by 2 matrix here. We have A11, A12, A21, A22. And we also have a matrix B, which is given as B11, B12, and B21, B22. Okay, now we want to add A plus B. Here we are going to be adding the corresponding elements together. So by the corresponding element we mean the ones that are in the same position, corresponding to each other. We have A11 is corresponding to B11, so we can add the two. A11 plus B11. That is, this one is first row, first column. Also first row, first column. We leave a space. Also we had A12 and B12. So we have A12 plus B12. Okay. So next row, also A21 plus B21. We have A21 plus B21. Then space again, we have A22 plus B22. So that is what we have for addition. Now, in the same way, subtraction, A minus B, we subtract the corresponding element. We can say A11 minus B11, A12 minus B12, then A21 minus B21, also A22 minus B22. So that's how to subtract as well. So we subtract corresponding elements of those matrices. For example, we can look at this as example. We have these two matrices. Each of them are of order 2 by 3. So let A be equals to the matrix 2 minus 4, 3, 5, 1, 0. Then also B, we have order 1, 4 minus 2, minus 3, 3, minus 1. So we want to find the first one, A plus B, and the second one, A minus B. So let's look at this solution. So the first thing we are finding, A plus B, we can just add directly the corresponding element. So it will just be 2 steps only. A plus B, that's 2 plus 1, minus 4 plus 4, 3 plus minus 2. So we should be mindful of the sign we have. Also 5 plus minus 3, 1 plus 3, 0 plus minus 1. So when we write the final answer here, we have 2 plus 3, 2 plus 1, 3, minus 4 plus 4, 0, 3 plus minus 2, that's 3 minus 2, 1, 5 plus minus 3, that's 5 minus 3, 2, 1 plus 3, 4, 0 minus 1, minus 1. So here this is A plus B. Then also we find A minus B the same way we subtract. As this we have A minus B. A first, because here you have to be careful, minus sensitive sign. So the other must be follow. A, that's 2, minus 1. Also minus 4, minus 4, 3, minus 2, 5, minus 3, 1, minus 3, 0, minus 1. So when we write the final answer, A minus B now, the same thing as 2 minus 1, 1, minus 4 minus 4, minus 8, 3 minus 2, that's 3 plus 2, 5. 5 minus 3, that's 5 plus 3, that's 8. 1 minus 3, minus 2. 0 minus 1, that's 0 plus 1, that's 1. So here we have also the value of A minus B. So that is addition and subtraction, how it is done here. So let's look at another subtopic here, which is scalar multiplication of matrices. So we have what is called scalar multiplication of matrices So let's look at this from here. What is a scalar? A scalar is just a number like any letter. So generally, let's say we have a matrix. So if we have a matrix A, which is a 2 by 2 matrix, written as A11, A12, A21, A22. Then we want to multiply this matrix by a scalar. We can scalar certain number. So let the scalar be k. Then you can say that k times a, which is scalar multiplication now, will give us ka11, ka12, ka21, a2. So this k is multiplying each of the elements we have in that matrix A. So every of the elements is being multiplied by the scalar. For example, when we look at this to demonstrate, let's given that A is equals to 5, 3, 4, 2 minus 3, 1. Then find 3 times A, 3A. So solution here, 3A is just going to be equals to 3. Multiplying this number, we have 3 times 5, 3 times 3, 3 times 4, 3 times 2, 3 times minus 3, 3 times 1. That is, 3 here is now equals to 3 times 5, 15, 3 times 3, 9, 3 times 4, 12, 3 times 2, 6, 3 times minus 3, minus 9, 3 times 1, 3. So that is 3 here. And that is all about scalar multiplication of a matrix. So thank you for watching in this class. So we stop here and we continue from there when next we meet. And thank you for joining. See you next class. And bye for now.